All right, section 8.2 is probably the most important section, or not the most, but it's one of the most important sections we're going to go over in geometry this semester. And it deals all with right triangle trigonometry. Okay, so right triangle trigonometry is used in a bunch of application problems in the real world, and especially when you get to higher levels of science, like physics, it's going to come into play regularly. So here's the deal. When you have a right triangle, okay, so you have this triangle right here. Okay, we have these trig ratios that we can use. They're called sine, cosine, tangent. Okay, with these, every single time, the sine of an angle, so I'm just going to say x, sine x is going to be equal to my opposite over hypotenuse. The cosine of x is going to be equal to my adjacent side over the hypotenuse. And then my tangent of x equals opposite over adjacent. Okay, so those are the three trig ratios that you're going to have memorized in this class. You're not going to have a formula, like you have to have that memorized. Now, the way I go about memorizing this is by saying SOHCAHTOA. SOHCAHTOA. All right, so if I go ahead and write that out, so would be SOH, so sine equals opposite over hypotenuse. Ca is CAH, so cosine is adjacent over hypotenuse. And then lastly, TOA, so tangent is opposite over adjacent. Okay, so those are my three trig ratios we're going to use, and those allow me to find the sides that we're going to be dealing with. So now the next step is we have to label our triangle. Okay, we have to label the sides of the triangle. In example 2, they want to know where the sine, cosine, tangent for angle H. So depending on what angle you're dealing with, our opposite adjacent sides are going to change. So you're going to have to label this triangle multiple times, okay? So I go ahead and go to angle H. Okay, it's all the way up here. And I want to label sides. Well, obviously 15 is my hypotenuse. The hypotenuse will not change because it's across from the 90. It has to stay there. My opposite and adjacents will change though. So if I go opposite of H, okay, go straight across, 12 would be the opposite. And then my last side left over, the one touching it, is the adjacent. Okay, so for angle H, I went ahead and labeled all the sides. And then now they want the three ratios. Okay, so they want the sine of H, cosine H, tangent H. So sine H is going to equal my opposite over hypotenuse because it's the SO of the SOHCAHTOA. I'm going to go ahead and go 12 over 15. And then as always, we should work on simplifying these. So you can divide both top and bottom by 3 and get the sine of H equals 4/5. Cosine is adjacent over hypotenuse. So the cosine of H is going to equal 9 over 15. Again, simplify. We're going to get cosine H is equal 3/5. Okay, so I got sine, cosine. Last one, tangent. You're going opposite over adjacent. So tan H is going to equal 12 over 9, which is going to give me 4/3. Okay, so really the key to this problem when you're finding your trig ratios is you have to go ahead, identify the angle, and then label all three sides. As soon as you have all three sides labeled, we go to SOHCAHTOA and start making our ratios, start making our fractions. Okay, so on example 2, you're dealing with the same triangle, but instead of having angle H, they want you to deal with angle F. Okay, so you'd have to go to angle F, label all your sides. So the hypotenuse will still be the same, but our opposites adjacents will change. All right. Example 3, they go ahead and give you special angles, so special right triangles. Honestly, we already quizzed on this and you have a formula for it, but if you wanted to. Realize you could also do this with sine, cosine, tangent as well. So for the 45, 45, 90, just go ahead and pick one of the 45s. Go ahead and label. So I got my hypotenuse, arrow out, opposite, and then here's my adjacent. So doing this, the sine of 45 is going to equal my opposite over the hypotenuse. Opposite over hypotenuse, so I got 1 over the square root of 2. You know that we can't leave it like that. You have to multiply both bottom and top by square root of 2, giving us the square root of 2 over 2. Okay, so that would be our sine. Cosine is adjacent over hypotenuse, so cosine of 45 is going to leave me with 1 over the square root of 2. Again, you'd have to simplify it like we did up there. So that gives us the square root of 2 over 2. And then lastly, the tangent of 45, opposite over adjacent, 1 divided by 1. It's just going to give us 1. For 30, 69, you can do the same thing. What do they want? They want the sine, cosine, tangent for all of them. Okay, so let's go for the 30. Sine 30. If I'm with my 30, my opposite is 1, my hypotenuse is 2, so the sine of 30 would be 1/2. Cosine of 30 is adjacent over hypotenuse, so touching the 30 is the square root of 3. Hypotenuse is 2. And then lastly for the 30, the tangent, we get tan 30 equals 1 over the square root of 3. We have to rationalize that to give us the square root of 3 over 3. Okay, so those are my sine, cosine, tangents for the 30s. I already have them for the 45s. Go ahead and try to figure it out for the 60. Okay, so remember for the 60, you go ahead, circle it, and then label. So I have hypotenuse, and I can't spell. You have hypotenuse, opposite, adjacent. Okay, so go ahead and do that one on your own. So sine, cosine, tangent of 60. All right. Last thing we're going to look at today is story problem. Okay, example 4. On example 4, we have to draw our own picture. Okay, so they tell us a plane takes off and climbs at a 12-degree angle. They want to know, is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles away from the runway? Or does the plane need to increase its angle of ascent? All right, there's a couple ways you can attack this problem, but regardless of how you attack it, you are going to have to draw a picture. So I'm going to draw a picture for this plane taking off the ground. Okay, you got a plane going up, and its angle with the ground is 12 degrees. Okay, so I go ahead and throw that in there. They tell you that it is 12.5 miles away. So, okay, we're trying to get over a mountain that is 12.5 miles away. So since that's 12.5 miles away, I'm going to throw it down here. Okay, and then we have a cliff somewhere over here. Don't know where. Okay, but you have a cliff somewhere over here. Okay, and I want to know, is this plane going to get high enough before that cliff to make it? Okay, so if I'm worried about how high the plane is going to get, we want to know, okay, what is the height it's going to be at 12.5 miles? So on this problem, what you have to do is go ahead, identify the angle they gave us, and then what two sides are we dealing with? So we are dealing with the opposite and the adjacent. Okay, you go back and think to our right triangle trig, so our SOHCAHTOA. Which of the three deals with opposite and adjacent? Well, it's going to be the tangent. So we know for this problem, the tangent of 12 is going to equal the opposite over 12.5. Okay, from here, we need to solve for the opposite side. So the way we're going to do this is on the calculator. Make sure that you are in degree mode. So on the yellow, you go ahead and mode, make sure you're in degree. And then from there, if I want to solve for opposite, I need to multiply the 12.5 up top. So you're going to have 12.5 times the tangent of 12 equals my opposite side. Okay, so we go ahead and do 12.5 times the tangent of 12. And we're going to get 2.66, we'll say is our answer. Okay, so I got 2.66. Remember, we're in miles. Okay, so you have 2.66 miles. Okay, that's how high the plane will be up. Question is will it clear an 11,088 foot mountain? Well, since it's in feet, you need to convert that 11,088 feet into miles. And we know 1 mile is 5,280 feet. So we go ahead and do that, divide it out. And we get 2.1 miles. Okay, so 2.1 miles equals the cliff. So if the plane is going to be 2.66 miles off the ground and the cliff is only 2.1 miles high, the plane will be over the cliff. So the angle is sufficient.